Namaskar, welcome to this first lecture on this course on Introduction to Infrastructure Asset Management. This course is being offered under MOOCs, an initiative of the Government of India, and I am Sudhir Misra offering this course to you with my colleague Professor Chirag Kothari. Now, in the first lecture, which is basically an introduction to this course, we are going to talk about the overview of infrastructure asset management. Now, as far as the conduct of the course is concerned, it will be governed by the guidelines of NPTEL or MOOCs, which dictate that the grading policy will be as under. There will be assignments, best 6 of 8 will be counted, contributing to 25% of your grades, and final examination will contribute 75%. As far as the assignments are concerned, they will be of two types. One is normal assignments where there will be a submission, grading, and solutions will be provided, and these are the ones that are going to be counted towards the grade. And then there will be do-it-yourself assignments, which will be basically reading and self-learning questions. Questions will be posed, but there will be no grading as such, and solutions will not be provided. In the discussion forum, we may try to provide some leads or thought process that may help you understand or develop the answer to the question that has been posed. Now, this is a discussion oriented course, and you will be expected to do supplementary reading on your own. Online courses give you an opportunity to self-learn, discern from the material available, learn at your own pace, and organize your thoughts. We will use this to the fullest as far as this course is concerned, but please note that the material used in the course is strictly for academic and instructional use here. Please do not use it for any other purpose. What you see on the screen is like what we saw in the good old blackboard. Please make it a habit to make notes as usual if you want, using what is visually projected and orally stated. Now, before we go into the course, I thought I will share with you what personally motivated us to offer a course of this nature. Engineers and architects are at the forefront of creation and maintaining all infrastructure. That is what our belief is. Having said that, the education process is largely focused only on the design of infrastructure. Now, these are some of the things which we will talk about in greater detail as we progress into this course. In technical discussion nowadays, we hear terms like performance-based design, sustainability, and resilience being thrown in, and they need to be put in perspective in a common framework. There is a pressing need to create awareness towards a more comprehensive approach to management of infrastructure assets and the issues involved therein. This is the kind of thought process that we had, which motivated us to offer this course on infrastructure asset management. Now, it is hoped that students from diverse engineering disciplines and architects, practicing engineers, architects from owner, contracting and or design organizations dealing with the creation or maintenance of infrastructure assets, and policymakers and users will all find the course and the treatment relevant and thought-provoking. I would say that if you have a genuine interest in infrastructure creation and maintenance, you should be able to follow the subject matter. Now, this possibly is the first slide as far as this course is concerned, and I have included this at the top because to me it is a very symbolic slide. What it shows is a bridge on the river Ganga, which was built about 150 years ago. Engineers realized that the bridge was in a dangerous position. It would be risky to operate the bridge or let the traffic be on the bridge, and therefore the traffic on that bridge was closed for close to 4 years. And one fine day, a span between two piers simply collapsed. Obviously, as I just told you, the bridge was not in use at the time of the collapse, and therefore, there was possibly no loss of life and no loss of property, in a manner of speaking. That said, to me, the question is that as a society, as a profession, is this how we want to treat our infrastructure? This bridge, which had been built 150 years ago, had served the transportation sector for all the 150 years. And when it was not functional, when it became old and had deteriorated beyond repair or whatever it is, it was just left to collapse. Now, that to me is a very, very difficult situation, and I would like you to think as to what can be alternatives. Can we have a more planned decommissioning of assets which complete their service life? Now, the service life is not in terms of economics. The service life is in terms of the actual time where the structure has been used. What this bridge and this particular example also tells us, that infrastructure projects have reasonably long lives. In this case, it was 150 years. And therefore, when we plan infrastructure, we have to keep that in mind, that whatever we are planning, constructing, that's going to be in operation for maybe 100 years. And therefore, it's not only the structural issues that have to be kept in mind, but also functional issues, issues such as sustainability, financial viability, and so on and so forth. That is the crux or the backbone of our discussion in this course on infrastructure asset management. Now, what are the expectations from infrastructure asset management? The management practices should be sustainable, they should be resilient, they should be adaptive to climate change, they should be backed by data-based decision making, and the approach should not be ad hoc. There should be a clear life cycle perspective, and strategic decision making should be utilized to optimize benefit. And finally, there should be a risk-based prioritization, which could be called reliability. Now, these are some of the words that we hear when we talk of this infrastructure asset management, except that we need to understand that all these words, all these terms need to be understood in the context of infrastructure management in a uniform way, and all stakeholders, whether it is users or it is contractors, the designers, the regulators, financiers, they all have to understand and speak the same language. They have to understand each other much better. What are infrastructure assets? What is the life cycle of these assets? Who are the stakeholders involved? How does an asset perform? What are the parameters that we can use to quantify the performance of an asset? Whether it's a bridge, or it's a building, or it's an industrial structure, or it's a road, what kind of a parameter will be used? Obviously, that parameter will not be the same across the board. So, each of these infrastructure elements will have their own parameters whose variation over time is what needs to be understood, and then we can talk about service life, we can talk about maintenance action and so on, and all these things are what we are going to be talking about as we go along in this course. That is what I just said. While we are doing the maintenance, the objective should be to protect, preserve, and keep the infrastructure in a functional form. So, this week the target will be to introduce the key concepts which I am just going to talk about, that we will use in this course through short lectures. These concepts could be a discussion on the stakeholders in the subject. Infrastructure, environment, deterioration and performance. Whatever infrastructure we are talking about is in a certain environment. It could be marine, it could be hills, it could be areas which are covered with snow for most of the time, it could be underground. So, depending on the environment, those infrastructure or those infrastructure elements will undergo deterioration, and that is likely to affect their performance. So, that kind of a thought process helps, or in fact is very important to have a background in before we start working on management of those infrastructures. So, there will be some discussion in detail as we go along in this course, and what we will talk about this week will be just a brief introduction to this concept. We will talk about the life cycle of the infrastructure. We will talk about inspection and data collection. Technology has enabled collection and storage of data at a scale which was unimaginable, maybe even 10 years ago. But that data has to be analyzed, that has to be better understood. Of course, there are technological tools being developed to help us analyze the data itself. At the end of it, there has to be an engineer who will lay down the guidelines as to how the data is going to be interpreted. That is something which is covered under inspection and data collection. We must remember that inspection is an integral part of the management of the infrastructure. As far as personal health is concerned, the doctor needs some inspection, some kind of data before the doctor can diagnose any disease or any need for intervention. There may be no need for intervention, but even then that data is required, and that is what we precisely do as far as inspection and non-destructive testing of infrastructure elements. Intervention actions during service life could be repair, rehabilitation, re-strengthening, or whatever we call them. All these have different connotations, they mean different things, and that has to be understood in a certain comprehensive framework, and that is what we are going to be talking about. Resource management is a very important part as far as management of infrastructure assets is concerned. There is always a tussle to use available resources to build new infrastructure or use the resources for maintaining the old infrastructure. Obviously, it is more glamorous, perhaps more appealing to build new infrastructure than using the funds or the resources available to maintain old infrastructure. But at the end of it, we as a society or profession need to tread a fine balance so that new infrastructure can be created as may be required, and the old infrastructure itself is also appropriately maintained. In this context, I would also like to point out that societies and countries or regions such as the United States or Europe, they went through a phase where the society needed the infrastructure maybe 200 years ago or 100 years ago, industrial revolution, post-industrial revolution and so on. So, they did a lot of building of infrastructure at that time, and now they are in the phase where the infrastructure needs to be basically maintained. There is some building activity going on, yes, but there is a lot of emphasis on maintenance of infrastructure, whereas societies or countries like India which are developing, there the emphasis at this point is on building the infrastructure. We need the infrastructure to improve the standard of living. Having said that, we need to learn the lessons from the West and other developed societies as to what measures need to be taken at the time of design and construction, so that the maintenance, the inspection, all these things become easier. That will not be required tomorrow, it will be required 20 years, 40 years, 50 years later, and that is what is comprehensive planning, incorporating the concept of life cycle design. Now, let us come to definitions. What is infrastructure, what is an asset, and what is management? All of us have very clear, or at least clear ideas. Right or wrong is a different matter, but we have clear ideas on what infrastructure, asset, and management mean. Now, as far as infrastructure is concerned, the dictionary meaning is the basic physical and organizational structures and facilities, for example, roads, buildings, and power supplies needed for the operation of a society or enterprise. That is what is infrastructure. United Nations defines infrastructure as something which supports economic development and human well-being and should be affordable and accessible to all. Wikipedia, if you look at it, defines infrastructure as a set of fundamental facilities and systems serving a country, city, or other area, including the services and facilities necessary for its economy to function. You are of course welcome to formulate your own definition of infrastructure and then think about and detail the role of engineers and architects. When I say engineers, I often include architects in that. So, my apologies to my architect friends that I may not mention them specifically at times, but I include them in that fraternity. Detail the role of engineers and architects in the creation and maintenance of infrastructure. Now, coming to asset, one of the definitions could be it is an item of property owned by a person or company regarded as having value and available to meet debts, commitments, or legacies. Investopedia describes an asset as a resource with economic value that an individual, corporation, or country owns or controls with the expectation that it will provide future benefit. Assets are reported on a company's balance sheet and are bought or created to increase the firm's value or benefit the firm's operations. Assets are also something that in the future can generate cash flow, reduce expenses, or improve sales regardless of whether it's manufacturing equipment or a patent. So, there are these different ways of looking at an asset. One simple way of looking at assets would be that say at time t is equal to 0, you had 1 lakh rupees in the bank. You choose to buy land for 50,000 rupees. Now, the moment you do that, what your 1 lakh asset base was has suddenly become 50,000 in the bank and 50,000 as land. So, now when it comes to infrastructure assets, how do we extrapolate this definition? That will be the real question. As far as bookkeeping is concerned, and that is what we often do when we talk of balance sheets of companies and so on, as far as bookkeeping is concerned, this asset that we bought, which was land here, or for that matter this was cash or a bank deposit, these have value that changes with time. Now, the question that I am leaving to you is to think as to whether these concepts of book value, depreciation, and so on are applicable to infrastructure assets. At the end of it, when we create a bridge or we create a road from point A to point B, a lot of money has been spent, and that money was sitting somewhere, and that has been converted into this asset, whether it is a road or a bridge or an industrial construction or a house or a residential complex or whatever it is. Now, that asset, as much as we maintain personal assets, whether it is jewelry or it's land or it's paintings, these assets also need to be maintained and managed. That really is the essence of our course. I am leaving it to you to refresh some of these concepts and definitions and be better prepared to discuss issues relating to infrastructure asset management. And when it comes to management, Wikipedia defines management as activities of setting the strategy of an organization and coordinating the efforts of its employees or of volunteers to accomplish its objectives through the application of available resources such as financial, natural, technological and human. We can also define management as a set of principles relating to planning, organizing, directing and controlling, and application of these principles in harnessing physical, financial, human and informational resources efficiently and effectively to achieve organizational goals. Now, this definition of management again is there in the books. The challenge is, how do we interpret, what do we interpret in the context of infrastructure assets, which could be roads, bridges, buildings and so on and so forth. Also, what is the role of technology and therefore engineers and architects in management of infrastructure assets? This is a loaded question. The question being asked really is, there are two ways of looking at managers of infrastructure assets. One is engineers and architects who are familiar with the processes that went into the design and construction of those assets, creation of those assets. They understand how the assets would change the behavior over time, but they have little understanding of societal good, cost benefit ratio, time value of money, depreciation and so on and so forth. And the other class of people is who have a clear understanding of some of these concepts in management, but they may need a lot of help as far as understanding the engineering and the technology that goes behind it. So, the question is, which set of people is better suited to carry out the job of infrastructure asset management? I guess I have already given my answer to it. You can think about it and come to your own conclusions. Now, infrastructure is characterized by high life expectancy, maintenance of a product and not a machine. Infrastructure assets are very often, almost always, publicly owned or controlled, and the investment involved is huge, and therefore, cost benefit analysis kind of a thought process is very difficult to apply. One of the reasons why the private sector was not playing a major role in the infrastructure development was precisely the huge investment and the complexity involved in evaluating cost benefit ratios and the benefits which may accrue immediately over a long period of time and so on. That is why it was only the government which had the funds to invest in infrastructure sector, whether it was transportation, whether it was defense or education, health and so on. These were key infrastructure which was publicly owned. Even now, the infrastructure is largely publicly owned, and you can make a survey of your own and come up with your own conclusions. As far as the growth of civil infrastructure in India is concerned, we now see a lot of emphasis on metros. We have a lot of emphasis on smart cities, ports and harbors. We are trying to get bullet train connectivity between Ahmedabad and Mumbai. Maybe there will be other corridors which will follow. There are large, I am not identifying this bridge, leaving it to you to think where we built this bridge and where we built this bridge. These are the kind of things that are going on in India. I said before that in countries like India, where we are building the infrastructure, obviously we will have a lot of investment in these sectors, in these projects, and it is important that our engineers are trained in the thought process of asset management, so that they create assets which are easier to manage. In the last decade, we have had a lot of development in the road sector, a 60% increase in the national highway network, 3.74 lakh kilometers of rural roads added, and an increase of 500% in the budget as far as highways is concerned. Airport infrastructure in India also has seen a huge boom with 84 new airports constructed. Schemes such as UDAN have been launched and 21 additional greenfield airports identified. So, this is all part of the emphasis that the government or the society in India has on building infrastructure. Now, a word about the life cycle of infrastructure. The first step is a concept and plan, where you say, okay, let's build a bridge, let's build a road from point A to point B, which will involve some tunnels, some bridges and so on. The next stage is getting down to business and carrying out the design. Remember that till such time as we complete the design, or at least a large part of the design, nothing has really happened on the ground. When it comes to the next stage, which is execution, you see that action begins on the ground. After execution, we have the phase of maintenance and operation. The picture here shows somebody trying to do a painting job on a building, which is a regular maintenance operation. Finally, decommissioning. That is the kind of thing that we talked about when I showed you the picture of the bridge in Unnao near Kanpur. And let me also say that if we leave the infrastructure which is not being used just to be on its own and wait for it to collapse or decay or whatever it is, it might be extremely detrimental, as we will see in one of the examples as we go along in this course. Now, here is a picture of some structures from ancient times that have survived the test of time. This picture is a more recent marvel that continues to be a part of the present day infrastructure. Find out more details relating to the construction and maintenance of this marvel. This is another modern marvel, which is the Aqua Line, which connects the city of Kawasaki in Kanagawa Prefecture with the city of Kisarazu in Chiba Prefecture and forms a part of a national highway. So, this is the Chiba Peninsula in Japan. This part is the Tokyo, this part is Tokyo, and this Aqua Line connects these two points here through a 23.7 kilometer road, which includes 4.4 kilometers of a bridge and 9.6 kilometers underneath the bay tunnel. Now, this is a man-made island which is created in the middle of the sea, where the transition from the bridge to the tunnel takes place. The important thing that I wanted to show with this kind of a picture, or perhaps the next one as well, is the scale of infrastructure creation. It is a huge investment. It is not easy to do these kind of projects, and therefore, it is important that adequate care is taken to ensure their durability and the fact that they continue to serve the society for a very long period of time. Please do try to find out more details relating to the construction and maintenance of the Aqua Line. This is another example from Japan, Akashi Strait Bridge, which was constructed about 25-30 years ago. This is another mega project under construction at that time, involving major commitment of resources, and finally it becomes a precious national asset. Here too you can find out more details relating to construction and maintenance of this modern engineering marvel. The idea of this course is not to emphasize too much the technical issues involved or the technologies used, but to understand that yes, modern technology, mechanization, modern materials, better understanding of material behavior, better understanding of the material environment interaction, better specifications have enabled us to build these huge structures, very massive structures, and it is important that we also understand the importance and the responsibility of maintaining them. In India as well, the Konkan Railway, the Vashi Mankhurd flyover, Kopili Dam, cooling towers in power plants, all these are examples of investments in infrastructure. Now, so far we had seen examples of what we build. Now, I want to show you some examples of structures, what they look like after a certain period of time. Now, the certain period of time is a googly. I am not naming how much time is involved, because that varies from structure to structure, and we will discuss it separately. Having said that, here is a structure. After some time, it is found that the concrete at the time of construction did not reach the ducts of the pre-stressing cables and left a void. As a result, the ducts and cables show a lot of corrosion. Similarly, here concrete is seen to be deteriorating on account of cyclic exposure to freezing and thawing. Here we have a situation where we can see progressive deterioration due to repeated applications of load, which is often called fatigue loading in technical language. Oftentimes, we have our structures in hot springs or other environments, and we can see a lot of deterioration because of that very special environment of hot springs. Corrosion, chloride induced corrosion, carbonation and so on, these are problems that cause cracking and spalling of concrete in reinforced concrete or pre-stressed concrete structures. So, the point is that what we build today over a period of time deteriorates depending upon the kind of environment that it is in, and that process, unless it is properly modeled, we cannot do management or maintenance of the asset in a scientific or in a rational manner. Let me assure you that different agencies owning the assets like the railways or the highway authorities, they have their own strategies for maintenance of their assets, but it is only a matter of comprehensiveness. So, I do not say that they are not comprehensive, but we are trying to put forward to you an approach that can be used across the board, better understand and based on the physical processes of changes in performance, changes in deterioration levels. Now, from all these examples, what I actually wanted to convey to you was the questions that an asset manager needs to be able to answer. Is the asset performing satisfactorily? How long will the asset continue to perform satisfactorily, and is any action needed or intervention needed? In order to be able to do this, there have to be physical models which tell us that okay, if the level of deterioration is here today, in the next 5 years it is likely to be here, and then somebody decides that whether to take action now or whether to wait and take action after 5 years or 2 years and so on and so forth. Now, in order to be able to answer these questions quantitatively, we need relevant data to be collected that requires resources. It is not easy to carry out an inspection and collect data from a bridge where accessibility is not provided for. Parts of structures which are part of the infrastructure system are very inaccessible. Anything that goes below the ground is typically inaccessible, and we have to have very special tools to collect any information that we want. Information from the design and construction stage should be available. Relevant information about any event or action in the past should be available. So, if we are looking at a structure today which was built, let us say 40 years ago, we must also have information as to what kind of repair, what kind of rehabilitation has been done on that structure in the last 20-30 years. And then we can probably make a better estimate or a better guess as to how that structure is going to perform in the next 5, 10, 20 years. Estimates of performance levels at different points in time would help. So, these are some of the strategies that we need in order to be able to carry out a comprehensive asset management. Poor infrastructure rating is not a problem in India alone. In the United States, the ASCE, or the American Society for Civil Engineers, in 2013, 17 and 21, they have declared their infrastructure condition rating to be a D, which is poor and at risk, and 43% of public roadways are in poor or in mediocre condition. As far as China is concerned, reports suggest 78.2% of the total roads need maintenance. As far as South Africa is concerned, the overall infrastructure condition is rated as D. So, the point again is how old is the infrastructure, and that brings me to the question that if the infrastructure is built at a certain level of quality specifications, it is likely to perform better rather than or in comparison to other infrastructure which is built at a compromised specification. So, these are the kind of thought processes that we will talk about as we go along in the course. Given that infrastructure creation requires massive capital investment, the question is infrastructure in a country related to development? In other words, because a country is developed, it has a well developed infrastructure, or because a country has a well developed infrastructure, it is developed? I am leaving this question to you, and you can think about it and come to your own conclusions. As far as infrastructure is concerned, let me give you some examples. It could be education, energy, health, defense, manufacturing, any amount of list we can create. There could be telecommunication, housing, water, transportation, agriculture and so on. And the point is that are they mutually exclusive? Try to find out if there are some interconnections. And again, what is the role of engineers and architects in creation and maintenance of these infrastructure, whether it is education, energy, health, defense, manufacturing, telecommunication and any other. Now, we need to break down the infrastructure. We need to understand it better by saying that okay, if it is educational infrastructure, it could be buildings, laboratories, other facilities for extracurricular activities and so on, equipment and manpower. Then there is another way of looking at education infrastructure. It could be primary, secondary, higher education, which is university, then there are research institutions. Education could be related to engineering, medical, legal, management and so on, and the kind of needs that these colleges, if it is an engineering college or a medical college has, are all very different, and that is what has to be understood very clearly in the thought process. There could be levels of education, there could be methodologies of delivery which are involved, and it will require different infrastructure, and that is what we need to understand when we are talking of education infrastructure. Similarly, if we want to break down the transport infrastructure, we could break it down into railways, roads, air and waterways, and if we want to break down the railway infrastructure further, you can look at tracks, stations, buildings, machines including rolling stock, locomotives, factories, power, telecommunication, colleges and training facilities, housing colonies and so on. So, there is a whole list of individual structures, individual structural elements that go into creating an infrastructure. So, that really is just the difference between infrastructure and a structure. So, different structures are a part of an infrastructure. Now, what is the role of engineers in creating them? And try to think of infrastructure related to defense and create a similar breakdown. If you are talking of defense, for example, you could be talking of army, air force, navy, a cyber kind of defense. You could be talking of space, and then each of them will have their own structures, and that is all part of the defense infrastructure. So, what we are trying to do in this course is to create a system by which we can at least conceptually look at asset management in a certain unified manner. Now, moving forward and trying to close the discussion for today, what we really need is a quantitative understanding of performance of an infrastructure facility. We need to understand the change in this performance over time, and that is an integral part of the effective management strategy. The parameter that we use for performance should be an integral part of the design process and serve as a benchmark to determine expected performance at a certain point in time in the future. And that parameter needs to be inspected and monitored as part of the inspections and maintenance processes in the infrastructure or that structural element over a period of time. For example, in a car, we can talk in terms of kilometers per liter of fuel as a measure. So, if there was a model which says that a new car gives you, let us say, 15 kilometers per liter, and as it ages, it starts giving you less and less, and you decide that the car will be scrapped or it will not be useful to you if the mileage that you get drops below 8. So, all these are arbitrary numbers, 15, 8, the rate at which it falls will depend on how you drive, where you drive and so on, but that is a number nonetheless. So, that is the kind of process that we are talking about and trying to see whether in the infrastructure sector we can find equivalent parameters for monitoring the performance. So, with this we come to an end of the discussion today, and in the next class we will talk about deterioration and performance changes over time in the infrastructure. And before we close, I will share with you a list of references or material for further reading, which will help you understand the subject matter covered today and being covered in this entire course. And let me end with an acknowledgement to all my teachers, colleagues and students in the last several decades who have contributed directly and indirectly to my understanding of infrastructure creation and maintenance. Some of the slides used include their input in different ways, and I am indebted to them for their permissions. Thank you.